If you're working with data, you already know that joins are pretty much the bread and butter of SQL. But what happens when your standard inner or left join just can't get the job done? Well, today we're going to upgrade your toolkit. We're talking about some seriously advanced SQL joins, the secret weapons that solve those really, really tricky data puzzles. Let's dive in. So let me set the scene for you. You've got a single table of employees, and inside that table, each person has a manager ID. Now your boss comes over and asks for a simple list, every employee right next to their manager's name. Uh-oh. How do you do that when all the names, both employee and manager, are in the exact same table? A basic join can't connect a table to itself, and that right there is why this advanced toolkit is so essential. So here's our game plan. We'll start by looking beyond the basics. Then we'll jump right into the self-join, the full outer and cross joins, and the incredibly handy multi and anti-joins. And to wrap it all up, we'll show you exactly how knowing this stuff can help you totally ace that next SQL interview.
Okay, let's get into it. Section 1, beyond the basic join.
Now, these aren't just some obscure commands you'll never use. They're very specific solutions for common but challenging situations. Think of them as the specialist tools in your toolbox for when a regular old wrench just won't cut it. Each one of these techniques we're going to cover unlocks a completely new way of looking and connecting your data. So, Section 2 is all about the self-join. This is the super clever fix for when you need to find relationships within the very same table. And here it is, that employees table we were talking about. See how Amit and Neha both have a manager ID of 1, and that ID of 1 points right back to Rahul. So the challenge is crystal clear. How do we link that manager ID column back to the name column in the same table? And here's where the magic happens. The trick, and you can see it right there in the query, is all about using aliases. We're basically telling SQL to pretend our employees table is actually two different tables. We'll call one E for employee and the other one M for manager. Then it's just a simple left join, matching the employee's manager ID to the manager's ID. So clever. And boom, there you have it. The result is exactly what we needed. Amit's manager is Rahul, Neha's manager is Rahul, and since Rahul doesn't have a manager himself, his field is null. That's a perfect use for a left join. Problem solved, clean and simple. So if there's one thing you remember about a self-join, let it be this phrase. Same table, different roles. You're just using one table, but you're giving it two different jobs to do in the same query. All right, let's move on to Section 3, full outer and cross joins. These two are all about creating the most comprehensive, all-inclusive datasets you can imagine. Okay, so a full outer join is your go-to tool when you need to see absolutely everything from both your tables. It doesn't care if there's a match or not, it just grabs all the rows from table A, all the rows from table B, lines them up where they match, and just fills in the rest with nulls. It's pretty much the most inclusive join you can do. Now, a quick but really, really important heads up here. If you're a MySQL user, you can't just type full outer join. It just doesn't work. Instead, you have to create it yourself with a clever workaround, basically by combining a left join and a right join with the union operator. That's a key little detail you've got to remember. Next up, we've got the cross join, which gives you something called a Cartesian product. Now, don't let that fancy name scare you. The idea is actually super simple. It doesn't look for any matching keys. It just takes every single row from the first table and pairs it up with every single row from the second table. So if you have 3 rows in one table and 3 in the other, you get a result with 9 rows. All possible combinations. So you might be thinking, why on earth would I want to do that? Well, it's actually perfect for generating lists of all possible combinations. Imagine you sell a t-shirt in 5 sizes and 10 different colors. A cross-join will instantly create a table of all 50 variations for you. It's also a fantastic way to generate massive amounts of test data. All right, Section 4. This one covers 2 incredibly practical techniques that you'll probably end up using all the time: multi-joins and anti-joins. I mean, let's be honest. In the real world, your data is never neatly tucked into just 2 tables, right? You almost always need to link customers to their orders, orders to the products, products to their suppliers, and on and on. Chaining multiple joins together isn't some advanced trick. It's just the standard, everyday way you build a complete picture of what's going on in any complex system. Now, this next one, this is a personal favorite. It's called the anti-join. It's important to know this isn't a specific command you type. It's more of a clever pattern, and its whole purpose is to find what isn't there. Think about questions like, which of our customers have never placed an order? Or which students aren't signed up for any classes? The anti-join is how you find those really important gaps in your data. And here's how you build it. You start by doing a regular left join from the table you want to check, like students, to the other table, courses. Then, and this right here is the secret sauce, you add a where clause that filters for rows where the key from that second table is null. That is null is what isolates only those students who didn't have a single match in the courses table. The easiest way to remember the anti-join pattern is to just think of it as asking the database a very simple question. Hey, give me all the records that have no match. So you've learned all the techniques. Now for the grand finale, Section 5, Acing the SQL Interview. Let's talk about how you can use this knowledge to really stand out and land that next job. Okay, interviewers absolutely love to test you on the fundamentals, so let's make this point of confusion super clear. As you can see here, the difference is actually really simple. A self-join works on a single table. It's looking inward, right? Finding hierarchies. A normal join connects two different tables to find relationships between them. That's it. You should 100% be ready for these questions. These are like the greatest hits of any SQL interview. So make sure you can clearly define a self-join, explain what a cross-join and a Cartesian product are, nail the difference between inner and outer joins, and of course, describe that anti-join pattern for finding unmatched records. And hey, here's a final pro tip for you. If you're short on time, if you can only study a couple of things, absolutely master the self-join and the anti-join pattern. As you can see, these two are always in the spotlight. Why? Because they really test your logical thinking, and interviewers just love to ask about them. So there you have it. We've just added 5 really powerful tools to your SQL toolkit. From finding a manager's name in a single table to identifying your customers who haven't bought anything yet, you're now equipped to handle way more complex data challenges. The only question left is, what mysteries in your own data are you going to solve first?